Page 209, Lecture 2.
We've discussed some dolphin behaviors that are very well understood, like feeding and reproducing. And we talked a bit about dolphin communication, which isn't as well understood, but there's a lot of research going on in that area. So, before we end for the day, let's look at one more behavior that I find really interesting, and that's how dolphins sleep. Now, let me first say that there are a lot of things we don't know about human sleep. And dolphin sleep is, I think, even more complicated and certainly harder to study. So you can imagine that the research is far from complete. But let's first look at sleep in general and then dolphin sleep. Okay, there are two ways we distinguish sleep from wakefulness, either by looking at behavior or by looking at physiology. And by physiology, I mean we usually look at electrical changes in the brainwave pattern, and that's, well, for humans at least, it's easy to measure those changes. And looking at behavior, we say that an animal has reduced responsiveness to external stimulation. So think of your own sleep. You're probably not responsive to things like voices, unless they're very loud. And except for a few really uncommon conditions like sleepwalking, a sleeping person is inactive. Okay, so if you want to know if a person or an animal is asleep, look at those two things, physiology and behavior. But if you look at only those two things in a dolphin, well, you're not going to get very far. Let's start with brainwave patterns. As you know, human brains, and dolphin brains too, they're actually very similar, have two hemispheres, two sides. We often talk about the right brain and the left brain. So when humans sleep, well, looking at the brain waves, you can tell that both halves of the brain are sleeping. There are distinctive sleep brainwave patterns. But with dolphins, what actually happens is one half of the brain stays awake and the other sleeps. And again, you can measure this. Measure the electrical activity in each half of the dolphin's brain. And throughout the night, or the time the dolphin's asleep, about every hour or so, the sides switch. The left side is awake and the right side sleeps, and then vice versa. And the dolphin's behavior while half of its brain is asleep? Well, dolphins in a group will swim in a small circle. They won't vocalize or communicate, no clicks and whistles. They'll have one eye open and one closed. That's right. They'll sleep with one eye open, and periodically they'll rise to the surface to breathe. So, what's the advantage of having half a brain awake and half asleep? Well, for starters, dolphins have to maintain some motor activity. They've got to get to the surface to breathe, and they need brain activity to tell them to do it. The other thing is, with one eye open and half their brain awake, dolphins can continue to monitor their environment. Now, it's unclear whether they mainly want to watch for predators or keep in contact with the other members of their group, but again, they need part of their brain awake to do it. And I should mention, it's not just dolphins. There are a few other aquatic mammals, seals and sea lions. Some species of seals and sea lions have this same ability to have half their brain awake and half asleep. So they'll sleep just like dolphins. But just some species. Other species of seals sleep much as humans do. The entire brain sleeps. For these seals, well, what happens is they'll hold their breath for a few minutes, sleep, wake up, rise to the surface, breathe, hold their breath, fall asleep, wake up, rise to the surface, breathe, and continue that pattern throughout the night. We're almost out of time for the day, but let me mention one more thing. We may be able to learn something about human sleep by looking at dolphin sleep. And let me say, I'm not going to suggest that humans train themselves to sleep like dolphins. That's not where this is going. But what we are learning from experiments with dolphins shows that it's the brain, not the body, that needs sleep. So, sleep serves a primary function for the brain, and it may be that the need for sleep is regulated locally within small portions of each side of the brain. That's going to be it for today. Make sure to read the next chapter before Monday's class. See you then.